Okay, the last section we're going to cover is 5.5, which is going to be combining everything we've done in 5.1 through 4. So you'll want to make sure that you really understand those other sections before you put them all together in this one. So our ultimate goal for this is going to be graphing. And I've listed the steps of the best order to do this in to help you kind of find everything you need to and not have to do extra work. So the first thing you want to do is look at the horizontal asymptotes. And remember, that's where if the number x squared and x cubed, if it's bigger on bottom, that's when you have y equals 0, bigger on top, you do long division. If they're the same exponent, that's when you do the fraction, y equals and that fraction. So there's three things. This is from 5.2. So look back there if you don't remember how to do that step. And then the rest of the steps use factoring. So we're going to go ahead and do factoring. And then we're going to look for what cancels. So like if you have an x minus 3 top and bottom before you go solve anything. Let's say we have that on bottom too. Remember, if it cancels, that's a whole from 5.3. And we would solve it. X minus 3 equals 0. You'd actually go and solve for x. Okay? Now, when you do this, the one that didn't cancel is your vertical asymptote, and that was from 5.1. So if you need details on that, go back there. And then asymptotes, you just found the horizontal and oblique asymptotes and the vertical, and those are dotted lines. So if you go over to like y equals 3, that's 1, 2, 3, so you put a dotted line. If it's vertical asymptote, it's an up and down one. Oblique ones are going to be diagonal lines instead of up and down. So you graph all of those. That's kind of your areas you can't touch on the graph. And then we can look at our factored form again and use it to figure out the x-intercepts. So remember, those ones are where you take anything left in the numerator and equal 0. And then your y-intercepts, we can go back to our original problem and plug in a 0 everywhere we see an x. And then solve it. And those are just points. So remember, x-intercepts go on the x-axis. Y-intercepts go on the y-axis. And then we're going to be using that testing that we did in somewhere in Unit 2, if I remember right. We're going to test a number in our original problem to see where to put the graph. And you don't have to do that for every single point. It's just to get an idea for each area. And then you sketch it. When you sketch it, remember, don't touch the asymptotes. And holes are an open circle where the function would be. So let's try problem number 1. So problem number 1, our first step again is to find those horizontal asymptotes. So 3 and x. X is bigger on bottom, so our horizontal asymptote is y equals 0. And then we factor. This one doesn't factor. So way easier. The denominator, x plus 3, does not cancel with the top. So remember, if that's the denominator, that's the vertical asymptote. So we subtract 3, subtract 3. So that's our vertical asymptote. So we have two things now. We have, HA, VA. Okay, next thing we're going to look at, and then we write no holes because nothing canceled. Okay, that's another answer. Okay, so when we go graph these, let's see, 0 and -3. So when you graph them, at y equals 0, remember y equals 0 is right here. So we're going to have a line, a dotted line right at y equals 0. And then at x equals -3. And then there's no holes, so you don't open circles. And then let's look for the x-intercept. So in factored form, it's just the top. Any of the parentheses that equal 0. Okay, so we have no x-intercepts on this one because we just had 3 on top, no x. Okay. And then y-intercept, let's plug a 0 in. So we have y equals 3, 0 plus 3 equals 3 over 3, which is 1. So y equals 1 is our y-intercept. So if you go over here, we know there's a point right here. And we know it's not going to touch the x-intercept. And then we're going to test a number in each area so we know how to graph it. The nice thing is, let's use a different color here. This one already has a number in this quadrant. Okay, so we have quadrant 1, quadrant 2, 3, and 4. It's been divided up by those dotted lines. So we know that this has to go over and touch right there, but not quite, like almost touch. And it has to go, oops, through the point. I am drawing awful. Through the point and almost touch the dotted line. If we test another number, like let's say I want to look at negative, what is that, 1, 2, 3, 4, 5. So that just means in my original problem, if I test negative 5, we get 3 over negative 2, which is about negative 3/2, so that's about right here. So I know my other graph is going to go like this. And we know, because it's a function, okay, keyword function, that in each area, there's only one graph in each vertical area. So like if I have a graph up here, I can't have a graph down here. Okay, so one graph vertically. So like because I have this guy right here, there's not a graph up here. So my final answer would be all those things boxed plus those 2 pink graphs. Okay, second problem, let's take a look. There we go. So this one's a little trickier because you do have to factor, but let's first start with the horizontal asymptote. So remember, you compare x squared and x squared. So those have the same exponent, so you do the fraction, so 1 over 1, which is just 1. Vertical asymptote is where we actually have to go and factor. So let's factor this really quick. So hippo butt, split up the x, split up the 8. We want a positive, so they're the same sign. Check the innies and outies, and you will get negative 6x here. On the bottom, we have x and x. The 8, let's split up. And we want opposite signs. So we want a positive and negative, and you check the innies and outies, and we do get positive 2x as our answer. So, holes, let's do that first. Anything that cancels. So x minus 2 canceled, so we do equal 0. We solve it. That's our hole. Our vertical asymptote was, let's do a different color so you can see it in my picture. So vertical asymptote was the bottom, whatever's left. So x plus 4 is a parentheses with an x, equals 0. Solve it. You should get a different number than your hole. Okay, on my graph, let's go and do that really quick. So here's a graph. Ooh, let's do a different color again. And we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Not the most accurate graph. When you graph, please draw them nice and pretty. So our horizontal asymptote is at y equals 1. So a dotted line through there. And horizontal being the keyword. We have a vertical asymptote at x equals -4, 1, 2, 3, 4. And we have a hole at 2, but we don't know where that graph is yet. Next, we're going to check our x-intercepts. Oops, we already used that color. Let's do blue. So our x-intercept was the numerator. So remember we had x take away 4 and x plus 4. This guy is the x-intercept. Or if we have more than one, that's okay. And we solve to get x alone. Okay, so we get x equals 4, so we know that at 4, so 1, 2, 3, 4, it's going to touch right there. And our y-intercept is just plugging in. Oops, y equals 0 squared, take away 6 times 0, so this is our original equation. 0 squared plus 2 times 0, take away 8. Solve that, and we get 8 over -8, which is -1. So at y equals -1, oops, okay, that's right here. So we know that it's going to cross through those 2 points. So already I know that for this, let's see, quadrant, let's show you. Sometimes you might have more than 4, but in quadrant 4 right now, it's got to go through those 2 points and not touch that pink line. It has to go almost to that green line, but not touch it. And then let's test a number to the left of the green line. So like negative, what is that? 1, 2, 3, 4, 5. Let's test it. So let me go over here. If I plug in y equals, and I test -5, so I'm just picking an area to the left of my green line. -5 squared plus 2 times -5 minus 8. Lots of big numbers. So we get 25 plus 30 plus 8 over 25 minus 10 minus 8. So that gives us 47 over 7, which is approximately, if you do the decimal of this, you get about 6 point something. So I go over to my picture. Oops, let's zoom in there. So at -5, we had 6.7. So 1, 2, 3, 4, 5, 6. So about right here, estimate. And again, you just know that it's not going to touch the pink or the green line. Oops, that was an awful graph. Let's get that out of the way again. So you just know it's going to go down and kind of scooch out. You'd have more room on your graph. You'd want it to look like it's kind of going like this, where it almost touches. And then we need to go back and fill in that hole. So our hole is at x is 2. So 1, 2. So I'm just going to put an open dot. And I'm going to try and get rid of the inside of that dot. So that's your final graph.